And hello, everyone. Welcome back to another episode of Schroeder News. I am your host for this episode, Philip Page. Now, electrostatic buildup inside of a fluid reservoir is a real thing and can cause irreversible damage to equipment and components. Today, we meet up with Jeremiah Allshouse to explain how you can prevent such static in your system.
My name is Jeremiah Allshouse, and I'm the Group Product Manager for the Hydraulic and Lube Filtration Group. Electrostatic discharge is a phenomenon that occurs when two dissimilar materials come into frictional contact with each other. This frictional contact causes a transfer of electrons, which makes the material either more positively or negatively charged. And when that material comes into contact with something else, there is that transfer of electrons that wants to go back and then causes a spark. It's similar to how you have wool socks and you would rub them on the carpet, and if you would reach out and touch a metal handle, you can see that spark that's created. Those are those transfer of electrons. So the same thing can happen in hydraulic fluid. So potential signs that you may have electrostatic discharge inside your system are the filter element may become burned or may see a lot of burned holes in there, causing less efficiency, less dirt holding capacity. You can actually visually see the burn marks on your filter element. You may see the breakdown of your filter oil, causing it to create this varnish or gunk-like contamination. You can see a lot of different components break down more quickly, some deflagration or increased risk of fire that can happen inside a hydraulic reservoir, and some other big ones like potential for arcing that can happen outside the system that can be dangerous for people who are working by this equipment. So electrostatic discharge has been known as an issue, but it's becoming more prevalent in today's world with the switch to more environmentally favored fluids out there. A lot of companies and manufacturers were using what's referred to as a Group 1 style oil. That Group 1 style oil contained a lot of heavy metal additives, such as zinc. And because of that, they had a higher electrical conductivity rating and didn't really see a lot of electrostatic discharge problems occur. But because of these heavy metal additives, they were considered carcinogens and very toxic to the global environment. So a lot of companies are now moving over to what's referred to as Group 2 or Group 3 style oil, often labeled as synthetic style oils. They have a much lower electrical conductivity rating because there are no additive packages of those heavy metals like zinc. And now that those have been removed, yes, they are better on the environment, but now are at risk of potentially creating electrostatic discharge inside the hydraulic system. Schroeder has come up with a few different ways to combat electrostatic discharge based on the level of electrostatic discharge that is prevalent in the system. We have both Anti-Stat and Anti-Stat premium filter elements that will remove or potentially eliminate everything altogether as far as electrostatic discharge goes in your system based on your fluid type and electrical conductivity rating. The filter elements are specially formulated to combat electrostatic discharge while still maintaining the high level quality filtration that is offered with our Excellement Z-Media. So when you're looking at your application, you're obviously going to want to look at your fluid type, and we can help do an analysis on that fluid type to determine what the conductivity rating of that fluid is. Conductivity rating is measured in units called picosiemens, and based on the picosiemens level, we can recommend a certain level of filtration or a type of media that best suits that requirement. So if we see that a fluid is above 500 picosiemens, we typically see that as a very low risk or pretty much no risk of electrostatic discharge. So you can pretty much use our Excellement Z-Media. But then once we start to fall below 500 picosiemens, in the range of 100 to 500 picosiemens, that's where we have seen the potential for electrostatic discharge. And then we would recommend our standard Anti-Stat media. But then when we have more high critical applications where your fluid conductivity rating is lower than 100 picosiemens, that's where we would recommend our Anti-Stat Premium option, as that is our far superior option at removing and eliminating pretty much all of electrostatic discharge in those high critical systems. Obviously, when we're looking at fluid conductivity rating, it's a case-by-case basis, so that's something Schroeder can help with, is analyzing your fluid to determine what's the best possible solution for you.
Between 2012 and 2020, the global market share of Group 1 oils fell by half, from 51% to roughly 26% of hydraulic oils in use. Now, this trend is expected to continue. While moving away from Group 1 oils is better for the environment, the rapid growth of low conductivity oils led to more electrostatic discharge in hydraulic systems. Now, if you'd like more information on Anti-Stat or other Schroeder products, visit us at www.schroederindustries.com or call us toll-free at 1-800-722-4810. Thank you for joining us in this episode. Until next time, take care. Bye-bye.